So this is a second video on the chapter for D-Day. This is on the non-scatter plot problem. So this is on page 2 and on. Oops, didn't mean to move that. Okay, so I'm going to start here. Now this is dealing with the scatter plot, but this is not the data that I was doing. So for this, what we want to do is we want to decide which one of these correlation coefficients best fits these. Now this is increasing, so this should be a positive correlation. Oops. Positive. This one is a negative. It's going down. This one is a positive. This one, I would say there's no correlation. You can't tell whether it's going increasing or decreasing. So that means that this R is 0. Now these ones are both positive, this one's negative. So there's only one that's negative. So this is going to be R is equal to negative 0.6. These two are positive, there's two positive. These are the two positive. Again, the stronger it is, the closer it is to 1. So this looks like these all form a perfect line. So this is going to be R equal 1. And then this one is good, but not obviously as strong as that. So that's going to be R equal 0.7. Okay, those are your correlation coefficients. Now the next part is review. So on a problem like this, this is dealing with, one way to do this is fraction busting. What I can do is I can times everything by 3 to get rid of that 3 in our denominator. So I'm going to go 3 times 5, 3 times x over 3, and 3 times 4. And now when I'm doing this, this 3 goes into this 3 one time, and now I don't have any fractions. So I am going to end up with here 15. Here my x, my 3's canceled, and I get a plus x is equal to 12. I'm going to minus 15 from both sides, so I get negative 3 as my answer. On number 4, we're just solving. Couple ways you could do this. First way is you can distribute that negative here. So you're going to get 6 minus 3 minus x equals 10. And then on this side, you want to combine like terms. So these are on the same side. So I am going to end up getting 3 minus x is equal to 10. I'm going to minus 3 from both sides, so I'm going to get negative x is equal to 7. And anytime you have negative x, we want positive x. So you can think of dividing by negative. I get x is equal to negative 7. And that's going to be your answer. Another way to have thought about this is you could have minus the 6 from both sides first. So this is just another way of thinking about the same problem. Okay, so if I have 6 minus 3 plus x equals 10, I can minus 6 from both sides here and here. You want to be careful, you still have that negative in front of this. Okay, is equal to 4. I am going to divide everything by negative, so I'm going to get 3 plus x is equal to negative 4. Then I'm going to minus 3, and I get x equal negative 7. So you see I end up with the same answer. So there's a couple different ways you can think about this problem. On the next one, number 5, this one we're going to be doing area model. Okay. This eventually is something we want to start recognizing when you have the same terms here in the front and the same terms here in the back, one with a plus, one with a minus. Down the road, this is going to be called difference of two squares. And it's nice to be able to do these quickly, but right now we're just learning how to do these problems, or just being introduced, so we can do an area model. So 3x minus 2, 3x plus 2, and then we're going to multiply. So the 3x is going to multiply with everything in this top row. So that's going to give us a 9x squared, a minus 6x. 2 is going to multiply with everything, so I'm going to get a 6x and a negative 4. Now what you noticed happen, and this happens every time we have one of these differences of two squares, when again they are the same in the front and the back, but one's a plus and one's a minus, that middle term will always cancel out, so we don't have any x's. And we end up getting as our final answer 9x squared minus 4. So the reason we call the difference of two squares, difference means subtract. We're subtracting two squares. This is 3x being squared. This is 2 being squared. But this is your answer. Okay, 9x squared minus 4. On number 6, laws of exponents. So for this, I'm squaring everything in here. So my 3 is being squared, my x squared is being squared, and my y is being squared. Again, everything's being squared. You don't have to write it out like this. I just want to emphasize everything in this quantity, since this is a single term, is being raised to the second power. So I get a 9, power to power I multiply. So this is going to be x to the 4th, y to the 2nd, and that's your answer. Number 7, they're giving us a function. And they want us to find f of 2. This is function notation. So f of 2 is equal to, this is where I'm putting 2 in for x, and I'm seeing what I get out. So I'm going to go 5 times minus 3 times 2. So again, this x is the 2 here. Okay. And so when I work that out, I'm going to get is equal to 5 minus 6. So I get a negative 1. That is my answer. So f of 2 is equal to negative 1, which basically means this. Okay, you don't need to write it this way, but I want you guys to understand that if I put in a 2, I get out a negative 1. So it's almost like, well, it is a point. Okay, this is my input, this is my output. Okay, but you can just give me negative 1 as your answer. Okay, on this one, we're going to graph. Okay. So I'm going to draw this. This is in y equal form. So this negative 6 is my y-intercept. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So this is my y-intercept, negative 6. So I'm going to go 1, 2, 3, 4, 5, 6. And then 3 is my slope. So 3 is really 3 over 1. And what 3 over 1 means is the top number is how far up or down you're going. Since this is positive, I'm going up 3. And the bottom number is right 1. So I'm going to go up 1, 2, 3, right 1. And then I am going to connect. So I'm just kind of, and there's my line. Okay. If I wanted some more points, I would go 1, 2, 3 over 1, and you see it actually would cross here. Okay. Number 9. Let's take a look at number 9. So on number 9, again, this is another area model. And this actually is going to be another difference of two squares when I have the same terms in front and in back, but one's a plus and one's a minus. But again, let's draw our area model. Okay, we don't need to, we may not know that yet, but we're going to learn down the road to recognize these things. So right now, we can just use our area model. x and a negative 2, x and a positive 2, and then I'm going to multiply this. I get x squared minus 2x. Here I'm going to get a positive 2x and a negative 4. And again, you'll notice that this negative 2x and this positive 2x canceled. And I'm going to be left with x squared minus 4. Again, a difference of 2 squares. Number 10, when you have this, I had written this out here. This wasn't here on your thing, I don't believe. Maybe it was on there. So what you want to understand is this is the same as this. So when you see an x plus 2, that is really an x plus 2 times x plus 2. That's what that is. So I'm going to do a box, x plus 2, a 2 by 2 box. And then I'm going to multiply this out. And so I get an x squared. I get a 2x. I get a 2x. Now this is going to happen when these are the same, when this is squared, these are going to be the same. Unlike here where one was a positive and one's a negative, they're both positive, they're not going to cancel. And then 4. And so I have x squared plus 4x plus 4. This is called a perfect square trinomial. Okay, again, just kind of throwing out some terms. We're not going to be testing on the name of this right now, but we want to start recognizing this. Perfect square trinomial. And that's when I have a binomial here being squared. On number 11, solving. Okay, I like to deal with my x's first. So I'm going to minus 2x minus 2x. And if you want, we can draw the line showing both sides of the equal. And I am going to end up having those cancel out. I get 3 is equal to 2x minus 6. I'm going to add 6, add 6. So I get 9 is equal to 2x. I divide by 2, and I get 9 over 2, or 4.5 if you want it as a decimal. Okay. Okay. On this one, we have another scatter plot. So here it's asking us what a possible R is for this, what a possible correlation coefficient is for this. So I'm just going to kind of draw a line in. Not that this is necessarily the line of best fit. I just want you guys to see if that's your line. You see that it is following the line, but it's not perfectly on the line. It is positive, so your R has to be positive. And here you're going to be trying to figure out, well, it's closer to 1 than 0 for sure. And you're going to kind of try to take a guess as to how much. Maybe I say it's a 0.7, okay? 0.7, 0.8. It's going to be strong, but not super strong. So I'm going to say that my R is 0.7. Again, this is not an exact answer, you can have a different answer. It has to be positive though. And I would say it's going to be greater than 0.5. Explain why you chose your answer in part 1. Connect your explanation to the scatter plot. So increasing line means positive R. The line is moderately strong. I wouldn't say it's exactly strong, so it's moderately strong. So not quite 1, but close. Okay, so it's off from here. It's not perfectly here. And again, I drew that line in. That line was not there. Okay, so that line was not there. I just kind of drew that in just so we could kind of see what I'm talking about. Okay, so on number 13, a study showed a relationship between the number of ice creams sold at a local shop with the number of drownings in that neighborhood. The newspaper is going to have an article titled, Stop Buying Ice Cream to Decrease Drownings. So this is kind of like that video I posted for you guys, or showed you guys in class, where it says ice cream kills. And that was meant to show you guys that sometimes there's a correlation, meaning there's a relationship. It can be modeled by a line, but it is not the cause. Okay, so write a paragraph explaining why this example is an association. Be sure to include at least two lurking variables. Okay, and so here I'm going to leave this for you guys to write your explanation, but you want to show that, and we kind of saw this in the video the other day, if we have our graph, and let's say that this is the amount of ice cream sold, and this is, so I'm just going to put ice cream, and this is number of drownings. Oops. Number of drownings. What's going to be happening is the less ice cream, the less drownings, probably due to weather. Okay, probably due to weather. So you might have kind of something like this, okay, where the more ice cream that's sold, for example, or eaten, the more drownings occur. And so some lurking variables could be the weather. So as it gets, if it's cold, you have less people buying ice cream. You also have less people in a pool swimming or at the beach. So there's gonna be less drownings. When the weather's getting hotter, you have more people buying ice cream. And when the weather's getting hotter, you have more people in the pool or at the beach. And that might lead to possible drownings. Okay, so again, I'm gonna leave that to you to write that. Okay, another area model. Now, this one is not any special name. This is not a difference of two squares, not a perfect square trinomial. I don't have the same terms in front or back. I don't have where one was a plus or one was a minus necessarily. We just have two binomials. And so we're just going to do a area model, and we're going to work this out. So we get 5x squared minus 2x, a 20x, a negative 8. So this is going to be 5x squared plus 18x minus 8. And that's your answer. Over here, solving for this one. Again, I can do this one of two ways. It's the similar type of problem as the one we had talked about before. I'm just going to do it one way. I'm going to minus the 2, minus the 2. So here, I'm going to do it the first way I did it. How about that? It's probably how most of us will do it. I'm going to distribute my negative. So this is going to be a negative 1 minus 4y equal 15. Okay, that's a y. It looks like a g. Then what I'm going to do is on this side, I have some like terms. So I am going to combine like terms. So I'm going to get 2 minus 1, which is 1. 1 minus 4y equals 15. I'm going to minus the 1, so negative 4y equals 14. I'm going to divide by negative 4, so negative 14 over 4. Or you can reduce by 2 and get negative 7 over 2. Or you can give it to me as a decimal, negative 3.5. Okay. 16. So here I'm going to fraction best. I'm going to times everything by 5 to get rid of that 5 on bottom. So 5 times 7 plus 5 times x over 5 equals 5 times 12. Multiplied everything by 5. This is going to be a 35. Here, this 5 and 5 are going to cancel, leaving me with a 1. And that's going to be a 1 times x, so that's going to be an x. And on the other side, I get 60. So I'm going to minus 35 from both sides, which is going to give me a 25, and that's my answer. On number 17, okay, so on this, I'm going to be substituting 2 in again. So 3 times 2 minus 2. So 6 minus 2, I end up with 4. So g of 2 is equal to 4. Again, my answer is 4. On 18, I'm going to make a graph. Okay, my y-intercept is this 2, so I'm going to start at 2. My slope is -3, so really -3 over 1. Since it's negative, okay, that means I'm going to go down 3, and then the bottom, always go right. Unless you're running out of space, then you do opposite. So I'm going to be going down 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, and then I can draw my line. And number 19. Okay, so number 19, let me just kind of move just this little bit here. I don't want to move all of that. Let me just move, see if I can just move. I'm just going to undo that. Okay. Well, we'll just read it through it right here. Okay. So we're looking at this problem right here. Okay, so this 2y is being raised to the power 3. So my 2, whoops, my 2 is being raised to the power 3, and my y is being raised to the power 3, and 2 to the third is 8, 8y to the third, and that's your answer.